2 in our calculators. Everybody remember how to do this stuff? I got 78. You guys get the same thing? And then 4 choose 2. 6, and then another 6, and then 44 choose 1 is what? 44. All right, so go ahead. The 44 choose 1, or where did this number come from? The fact that there were 52 cards, and then we want to, this is picking the last one, so this is like picking the 6 right here. It just can't be a king or a queen. So if you take 52 cards minus 8.
Any king or queen?
Right, because if it was like, if we had 2 kings and 2 queens, and then our last card was also a king, that'd be a full house, which means 3 of one, 2 of another. So it has to be something different, and there's only 44 cards that aren't kings or queens.
Okay.
Good question. All right, so 78 times 6 times 6 times 44 on top, divided by that 2 million number. I got 0.0475. Let's go 5 decimal places. We'll also put a 4 after that. This is for 2 pair. 0.04754. So are your chances good to get 2 pair? I mean, good? No. But it's 5%. Like, that's 1 in 20 hands you'll get a 2 pair. That's not improbable. That's not unrealistic. If this was the probability of winning the lottery, I'd be playing all the time. Do you know what the probability of winning the lottery is?
0.00000.
We'll have to do that. Let's do that maybe as a warm-up this week. But you see this one? This is more probable than winning the lottery. Far more probable. I mean, as long as we're talking about the big prize. If we're talking about like winning $10 or winning even like $50,000, that's far more probable than the $1 million jackpot. And if you're like, well, then why does it even happen? Because there are millions of people in the U.S. and people buy multiple lottery tickets. And sometimes it doesn't. Like, haven't you seen the things where it's like the Mega Millions jackpot or whatever it is, nobody's won it in like a month, so it keeps on building, and then finally somebody wins it, right? And yeah, if I was playing poker with the whole United States, I bet somebody would get a royal flush. If everybody in the United States was playing. All right, now we're gonna try the probability of getting a straight on the first draw. Number 6. So what you missed is that I'm doing 5 of these with you, and then 4 of them will be your homework to try. And do I expect you to get all 4 of them right? No, I expect you to try your best, and then we'll talk about it tomorrow. Okay, let's try number 6. Find the probability of getting a straight. Now, the best way I've found to figure out the probability of getting a straight is to write out all the options for a straight, which is the first thing we're going to do. So the first option, we're going to call aces high or low. It can be either. So ace 2, 3, 4, 5. That's the first straight you could get, right? Next one is 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. I know this feels like it's going to take a long time, but it will be over very quickly. 4, 5, 6, 7, 8. Do you guys see what I'm doing? And then 7, 8, 9, 10. Jack. Okay. I missed one? Right. It's not necessarily a royal flush, right? It's just a straight, but a royal flush would be in there. So one thing that we're definitely gonna have to do is we're gonna subtract the possibility of getting a royal flush. Okay, all right, so getting a straight. It looks like there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 choices of straights we could get. On the bottom is 52, choose 5 like normal. Which is 2,598,960. All right, there are 10 straights to choose from, and we're gonna have one of those. So, Charlie, pick which one you like the best. Which straight do you like the best?
Oh, the 10 Jack Queen King.
That one?
Yeah.
Okay, so let's say we're picking this one. How many 10s are in the deck? 4. And how many do we need? One of them. Okay, and then how many jacks are in the deck? 4. And we need one of them. Same thing with the queen and the king and the ace. Okay. So then I'm going to write 10 choose 1 is 10. 4 choose 1 is 4, but there's 5 of them, so I'm going to write 4 to the 5th power. Okay. And then what it does is it subtracts all of the flushes. So there are, there's 10 of these, right? So what if all of them were diamonds? Like if it was a 6, 7, 8, 9, 10 of diamonds? That would be a straight flush, which is up here. So we're going to subtract the probability of getting a straight flush. So maybe I'll do that one with you too, and I'll do one more. So let's just figure out this probability for right now. So everybody type in 10 times 4 to the power 5. Divided by 2598960. 0.00394, but we're not done yet because we're going to subtract the probability of getting a straight flush. Okay. So I lied. I'm going to do 6 of them with you and give you 3 as homework. So go up to number 5. This one's going to be really easy. There are 10 choices to pick from. So a straight flush means that they're all in a row and that they're all the same suit. So they're all hearts, they're all diamonds, etc., right? All right, so Gavin, pick your favorite straight.
Ace. Start with ace.
Okay, so this one is the one Gavin's picking. There were 10 choices that he could have picked, and he picked one. And then if you wanted them all to be the same suit, how many choices are there for them all being the same suit? No, that's how many different types there are. How many suits are there? 4. So there's 4 suits, and we want 1 suit. And that's it. So this one is 10 times 4. Something I mentioned to everybody, so that you don't get worried about it, Renee, is I'm not going to put this on a test at all. So this is just kind of like extra, trying to go over and beyond and trying to help you guys understand it. But I'm not going to hold you responsible for this. I got 0.000015. You guys get the same thing? Okay, so then down here, we're going to subtract the probability of a royal flush, or not a royal flush,